Hey, I have a question. How many Newton meters is that Tat gun of yours pushing, huh? What about the speed torque curve? You got a pretty steep curve on that tatty slapper of yours? You don't have any idea. And you call yourself a professional tattoo artist. Hey, welcome to the Fireside. My name is Jake. Very happy to be back on the internet with you guys again. We haven't done a whole lot this year. We kind of took 2022 off for the first half. Just no good reason. We just haven't had a whole lot to say. I didn't feel like I had much to contribute. But today you're in for a treat because we have our good friend Carson Hill back on the show. Carson of Neuma Tattoo. And you might remember, if you've been following the show for a while, that last year we did a 5-part series on rotary machine technology. We compared coils and rotaries and the pros and cons of each. And we did some pretty deep dives into the technology of rotary machines. And we focused a lot of that around Carson's Neuma 4, which at that time was was his first machine he had put out in quite a few years. And that series was awesome. It was really well received. I learned a ton on it. If you haven't seen that series, you can go on our YouTube channel and just look at the playlist machine review episodes, and his episodes are in that playlist. Or another idea is that you could use the link in the video description below and sign up for our gear and tattoo technology newsletter, and we will send you each of those episodes, I think one per week, to your inbox, and you won't have to search on YouTube for them. You'll also get other gear and tattoo technology related content that we put out in the future. That's what I would do if I were you. This episode today, we're talking about Carson's newest invention, the macro, the Neuma macro. And when I talked to him about this initially, he told me that it had 50% more torque than the Neuma 4. To which my response was, why in the world would you need that machine to be more powerful? I think I could tattoo someone through a drywall with this thing if I needed to. It is such a punchy little machine. But as we talked, and we'll get into here in just a minute, as we talked, I realized that torque plays a different role in rotary motors than just speed and power. And there is kind of a breakdown, and that's kind of the joke that I was telling in the intro about Newton meters and curves, torque curves, and all of that. We'll get into that and talk about what that is and why you should care. So that's it. That's all I want to say. I want to get into the episode. Thank you guys, as always, for supporting what we do, and I hope you enjoy it.
The way that I build tattoo machines is I select motor first. So I'll go through and I'll pick out a bunch of motors and I'll test them all and see, what characteristics I like, don't like, and then, either keep looking, buy more motors, try make more tests, this kind of thing. And so I landed on the original one, and then later discovered that there was a series with another one that's very similar, but with a higher output. So I thought, oh, well, why don't I test that? It seems like it would be pretty easy to test because the platform that we're using for the N4 would be almost the same. We can make a couple small modifications and see, just at least for testing purposes, and test and see what if it's worth exploring. So we did that, and I think I made 5 prototypes of that, and sent one to. So I kept one. Actually, I kept 2. Sent one to Baxter, one to Mike Cole, one to Ty Pilata, and eventually the second one that I kept sent to Chris Oppenheim, so that we could start testing them as a group and sort of see what we think, right? And then kind of the business sort of got me distracted. So I was using it almost the entire time. There were times when I had forgotten that I was using it because they look so similar. It's the same motor. The length is changed. So, okay. So it's almost identical when you see them side by side. In fact, I have 2 of them sitting right here, and you can see this is the new design. So you can see that the difference is length, and that's it. The grips are the same, and we'll get to that. That's partly the explanation.
And this is the what became the modus or the macro?
This is what became the macro.
The macro, okay.
Macro So modus in Latin is basically like mode or like standard or normal, but it also means like a deviation from normal. So I kind of liked that because I feel like that defines what I'm trying to do here. And then macro means large or big, great, this kind of thing. So that's why they're named what they're named. And then like mode of or modus operandi, I'm sure you've heard that, basically means like mode of operation. So I wanted to kind of within the name of them illustrate what the purposes for them were. And the truth is that my intended purpose of them was one thing and has kind of become something else I've learned along the way. I mean, it is both the same, both the intended purpose and more, kind of is what I should say, I guess.
Can I back up and ask why you needed to explore further beyond the Neuma 4 that I own and that you've sold so many of? What was there something that you felt that it was someplace you felt it was falling short, or it's just in your nature to try to continue to push and see what else you can do?
Yeah, it's definitely part of who I am. I just want to explore and experiment and try things. And this, so the macro, back to the macro, like it being 50% more torque, and very easy for me to prototype. It was kind of like, well, I can't not, and I had already tested. I mean, I don't know how many motors I've tested, a lot, maybe get 10 or so, maybe a dozen. And so it's a normal practice for me to play with motors and see what works, what doesn't, and why. I actually have been using both the N4 and the macro for about a year and a half at this point. And it had kind of gotten out of my mind, to be honest with you, because so many other things have come up in business and we're constantly doing things and we're very busy. And so it just wasn't on my mind. What happened was Baxter called me one day and said, hey, what's the name of the machine? Somebody's asking me my preferred, setups. And I can't find that machine on your website to like recommend it. Where is that? And it wasn't there because he was holding a prototype. He knew it was a prototype at the time. I gave it to him, but I think he didn't realize it has just never been developed. So when all that happened, and I had been using it too, and Mike had broken his, and then I haven't talked to Ty in a while, so I'm not really sure if he's still using it or not. And then the other guy, Chris, he's been using it the whole time as well. So I kind of like touched base with everybody and just decided, okay.
How did Mike manage to break his? Any idea?
He dropped it. I think he dropped it twice.
Oh, okay.
Yeah. That's the downside to these things. You drop them from 3 feet. They're kind of delicate, and they can. It still runs. It just runs bad. So anyway, so we decided to go forward with making macro, and so the intention was this would be the big mag pusher or the big needle grouping pusher. If you want to do large scale work, this might be a better machine for you. Or if you're always doing hard and aggressive, hard and fast tattooing, that might be a better option for you. But yeah, like pushing, like I'm sure you've noticed if you ever use like really large mags.
Well, not huge. No, I use 15s most of the time.
Yeah, same as me. I don't really use a whole lot of them, but when I do, and even with 15s, but particularly when you go past that, you get into like 25 territory, even 35, which I don't do a ton of, but when I do, I always notice that the machine wants to bog out a whole lot easier, right? Even with a 15 compared to a smaller needle, right? So the idea behind this was, this is gonna be your big mag pusher. This is gonna be like your heavy hitter kind of thing. Some of the things we discovered is that so the characteristics of the motor are basically you have a flatter, what's called a torque slope or speed torque slope. So ultimately what it means is that you in the lower RPM range, and in the so there, with electric motors, it isn't really a curve like a fossil fuel engine, right? Where you have like really high peak and then it drops off, and but it's similar, but it's usually like a straight line. They call it a slope. So basically, some of the benefits of having more torque and a flatter torque slope, as it relates to tattooing or this specific machine, are that in the lower RPMs, you still get a hard hit, and then you don't really find a peak. So in the higher RPMs, you're also still getting a hard hit, but you don't really need, so typically the way that it works is torque and speed are linked in an electric motor. So if you want a lot of power, you have to get some speed in order to get there. And so the downside to that is that if you want to run slower, but you still want the hit, then it's kind of a give and take. But this machine having a flatter torque slope, it kind of eliminates that problem to some degree. Okay. So there's that benefit. And then also so actually the Modus, so the smaller one, it has the same motor as the original, the N4. Same motor, same mechanism. It's the only changes really are ergonomics in this.
Okay. So it's essentially replacing the N4. Like, will you have this and the N4 that the Modus and the N4? Or will it?
We have it, and we still offer it. I kind of expected it to replace, but we are still selling it. So I won't take it away from people. If people want it, I'll continue to offer it. But it's the same machine. Like internally, it does the same thing. It has the same parts and everything. It's not like you get Modus cams and N4 cams and they're all the same.
So the cams are the same across all three versions.
Yep,
Okay.
and the bearing arms as well, and the springs. So it's all the same. The only real difference between the Modus and the N4 are the ergonomics. So this is the original N4, and then this is the Modus. So you can see that it's a little bit longer, not much. The grip is longer, and then you can see the end cap's a little taller, but they're pretty similar. The diameter is, this is actually a 33 and this is a 27. So it is a little bit bigger, but we also changed the ergonomics of like these finger grooves. It's a little bit more comfortable, and then the cartridge is keyed in with that. So as you install the cartridge, like the flat of a mag aligns with the flat of that. So it's just a little bit more thought went into it than this. This is kind of just these grooves that were meant for traction and that kind of thing, but nothing beyond that. And then the cartridge receptacle is random, not aligned with anything. Right. And then obviously
dial is,
it's a lot bigger. And that is for two reasons. Number one, when you're operating a battery pack, getting your finger in there is a little bit of a pain in the butt. So that helps with that. And then also just having a bigger, meatier thing to grab onto makes it easier, gives it more leverage, so that you can turn it easier.
I could see that being useful. One thing that I've noticed, and I don't know what version I have, I bought mine early on, but one thing I'll notice if I don't adjust if I don't twist the dial or the grip kind of early on, if I start to tattoo and run the machine, I already have my sleeve over it and my co-band and all the stuff that I put on. Sometimes it feels like it's not really seized up. It's just getting it to start to turn for the first time. I'll have to be like, oh, I'm gonna have to pull this back apart and like actually unthread it a little bit and start it back over. I could probably fix that with a little like grease or something on the threads, but I never think to do that. And I was just thinking a heavier dial might make that a little easier to do.
Definitely makes it a lot easier. You would be surprised how much that little bit makes a difference.
Yeah,
that was actually Mike's input. So
yeah. So with the macro, what do you? I mean, I guess if the cams that you're offering and the bearing arms and all of that stuff are the same all the way across, do the recommendations change based on the torquier motor, or do you still, if you like a 20% for 3.6 or whatever for lining, will you still use the same setups basically?
Yep, I would still recommend the same, yeah, same stuff as far as cam and stroke profiles go and stroke lengths go. It's, it's going to be based on what you're currently doing and your preferences. It
Mhm.
still has the same effect. It's just going to give you a harder hit.
Hmm.
And then the other thing is that having, there's a couple other things that we noticed that we didn't expect. So the motor is bigger. That means it has more rotational mass. So that mass is carrying inertia, and so it acts as almost like a flywheel effect. Sort of like we have those brass bearing arms, right? Which gives it a kind of a smoother, stores energy, and this. So it has a similar effect to that, where, or at least that's kind of our interpretation of it. It feels a lot smoother because you're not. So with the Modus, it has a 6, or with an N4 / the Modus, it has a 6.8 millinewton meters of torque output, and then the macro is 10. So it's quite a bit more. Technically so the max speed of the motor we're using for the Modus and the N4 is a little bit higher than the macro, but because that motor is so much stronger, once you apply all the load of the spring and the cartridge and skin, the torque of that motor overcomes all of that a lot easier. And so it actually ends up giving you a higher rated speed, which is, like speed within actuality while you're actually using it. So it's going to be a little bit faster and a little bit harder hitting. And then it's also more stable across so like the interaction with the skin, for example, is not going to cause as much bog. It's going to be it's not going to slow it down so much, right? So because of that, that extra torque, it's not as sensitive to load, basically.
In the last series, we talked a bit about bog, like in coil machines and the effects of bog, and we talked about dwell time in the skin, and we kind of mapped the rotation of the rotary machine and how it translates to the cartridge, and how it accelerates and then it slows down at kind of the top of the curve, and then it comes back out. Does the torque of the machine change any of that stuff fundamentally, or is it like?
So according to geometry and the fundamentals of it are coming from the geometry of so no, the answer should be no. But in practice, it does seem to make a difference, and I'm not entirely sure what's causing that. I'm not really sure. I know that when you give people these machines, they work more efficiently. They don't need as much voltage and speed in order to create. Or it's kind of hard because you're not really looking at the speeds. You're looking more at the voltages of these machines, right? So feedback that I've gotten is people are turning them down compared to what they're used to with the N4 standard. So, and then they're also saying no snagging, less snagging. So, I mean, I'm not experiencing snagging with the N4.
I haven't either, yeah.
But then you have guys, so like, I only have a few people that are using production models at this point. So I'm talking about their feedback at this point. So like Howie is one of our, who Howie is? So he is very fast and very aggressive and all about saturation and, heavy lines and so forth. And he says, oh, I've been working faster and faster and faster. So I went and brought him one the other day, and he said, oh, well, now I turned it down and now I'm not getting snagging. So it's hard to say exactly how people are experiencing stuff because there's so many variables, but that's some of the feedback that I'm getting so far.
Yeah, I was amazed. When I got my N4, lining, it lined for me perfectly, better than any pin style machine I had used instantly. I struggle a little bit with solid saturation, playing with voltage, playing with the different cams. And it took me a while to kind of dial in where I wanted it. Part of it is that some of our early conversations, we were talking to Ty, and he was using like the 40% cam at like 8 or 9 volts, something like something way faster than I would ever run a machine. So I started kind of probably higher than I should have and worked backwards instead of going vice versa. And I was getting a lot of kind of swelling and stuff like that. So it took me a little while to dial it in. I'm surprised that Howie, though, had a problem with snagging, because one of the very first like super successful tattoos that I saw that I knew was done with the Neuma 4, Howie had done, I want to say it was like a pineapple or something, but it had this like seafoam blue all behind it as like not as a wash, but as like a background kind of pattern. And there was absolutely, that kind of like light teal, it like irritation just seeps through it instantly. And it looked photoshopped almost. And so I texted him immediately and I was like, you did that with the Neuma 4? And he was like, yeah. And I was like, dude, I cannot get it to saturate like that yet. And so I just assumed that he had figured out instantly, like it just worked with the way that he moved his hand right out of the box, whereas it took me a little bit longer. So I'll be curious to see what he does with this one.
Yeah, me too. I'm excited to see. He did one tattoo with it, and then he went out of town. So we'll see.
Okay, yeah. What are you? So this is May. Like you designed it to be more torquey to push larger needle configurations. Are you using it to line with, say, a 7-liner or something or anything like that? Or
yeah, I personally am. To me, it's kind of, I mean, I don't do a lot of really like delicate stuff or black and gray, super soft stuff. So I would still recommend, if somebody was more that style of artist, that they go with our normal Modus or even the original machine, because they hit the same. But comparatively, I think that the macro is probably too hard of a hitter machine for certain things. But for someone like me, who does almost entirely color and heavy line stuff and like saturation and stuff like that, the macro is it's ideal as far as I'm concerned.
Yeah, and you do a lot of layering and things as well, right? So and you have it in the torquiness of the force that it's hitting with isn't affecting your ability to make multiple passes over an area or anything like that.
No, it's not like such a dramatic change that it would cause me to have to change my way of tattooing. It gives me a little more, basically.
Yeah. What's your kind of voltage range personally that you're using the macro in?
I still basically use it right around the same. I mean, I would say if anything, maybe a little higher, but I think that's partly due to just my evolution. It's not really about the machine, and I kind of experiment a lot. So I would say, whereas I think last time we talked, I was more in the 6-7 for coloring and maybe 7-2 for line work. I think now I've kind of upped it a little bit, and maybe it's more like 7-2 is maybe as high as 7-7 for lining, something like that. So it's not a huge change, but my approach or my philosophy is, if I can get it done more effectively or more efficiently, and then I'm going to.
Yeah.
Although there are going to be certain circumstances where I feel like I need to slow down. I actually find that I can get a tattoo more effectively done sometimes at a lower RPM or a lower voltage.
Yeah. Have you found that when we first started talking, you were not super high on using battery packs for the original N4? Have you found that you're using batteries with it more, and is that making a difference with the macro and is it draining batteries, or is it causing trouble with batteries?
It's actually about the same, which is a little bit of a surprise, but it is still, so they're both 8.5 watt motors. One, you would assume the larger one with more output and more speed is consuming more power, but it isn't, or it doesn't seem to be. And if it does, it's a small amount. Howie seems to think he's getting more. battery life out of it. I don't know how that would be possible. But the truth is, I was thinking about this earlier today, actually, that when I do my battery life testing, I will set it up at, say, 8 volts and just run it until it dies and set a timer. So it's got a cartridge in it, but it's not really under
load or anything.
like tattoo circumstances. So maybe I need to modify my testing to try and determine that. But my guess is that, well, I mean, it's kind of contradictory. I'm not really sure because I turned the voltage up a little bit. But
yeah.
The couple of people that I've spoken to have said that they turn it down to get the same results. So it might be just that it's operating at a better efficiency, and so it's not really sucking up the juice quite as quickly.
Yeah, I don't have a good idea really about what how a motor is built to be more or less torquey. But when I think about the limited amount of electrical knowledge that I have, I think about the differences in a 220 volt system of any kind, air conditioner or out in your shop for welding or power saws or whatever else versus a 120 volt system. And your thought is if it's 240 volts, 220, 240, that it would draw more power, be more expensive to run, get hotter, because there's more electricity flowing through it. But it's the exact opposite. 220 volt systems are far more efficient. The mechanisms that that you're powering typically last a lot longer. They stay much cooler. It takes far less energy to run them. And I think it's because of the electrons can move more freely through the conduit because there's twice as much space for them to flow through. So heat being a byproduct, it produces less heat. I don't know if that has any translation to a motor that's more torquey. I don't know if the wire is a heavier gauge or what makes one motor more torquey than another. But
well, so in this case, because the two motors are from the same series, and they are the same diameter, it's the same motor, same series, same diameter, different length. So my assumption is that the magnets are longer and the coil is there's more windings. So in that case, there will be more magnetism, and in that, that's how it's achieving the higher torque. And then because there's more rotational mass, it would make sense that it's not going to have as high of a top speed, because a smaller weight would be easier to spin fast than a bigger weight. But that is also with a limited understanding. I only know so much, and some of that is just assuming.
Yeah, it would be interesting to learn from someone who actually builds rotary motors. Do you have, like you said, you've tested probably 10 up to now. How are you deciding? I've never looked for rotary motors for any purpose whatsoever. How are you deciding who you're buying them from, which ones you're testing? Is it like just a contact that you have or someone you worked with before and you're trying to stay with the same manufacturer, or are you all over the place?
I mean, I've gotten motors from a couple different manufacturers, but Fallhaber is my preferred brand. They have a really good reputation specifically for small motors. And I do have contacts with them. So I have had several meetings with engineers from that company who are happy to give me information and answer questions. I have lots of questions for them often. So yeah, I don't really have any like brilliant methodology. It's really just a lot of experimentation and trying it out, because you can, like I've stared at charts, right? The data sheets of I don't know how many dozen motors, maybe hundreds of motors, right? And of course, I always start there and try to compare numbers and, so for example, most of the like top brand pens that people are using out there today are using the same motor. There are a handful of them. And so and the mechanism is more or less the same as well. But so that's why they feel so similar. But they're all using a 3.1 millinewton meters of torque output motor with a rated speed of roughly 3,400 RPMs, which sounds to me like very slow. So my philosophy has always been, let's give them a little bit more power. And my approach has always been like, I'm going to bring the tattoo industry something that they didn't know that they wanted, right? So speed and power. And I think that those are the two things that I, as a Rotary user, would complain about in my past. Like that's what's missing, besides the stroke profiles and that coil feel and things like that. If we're going to remove those, then it's like you want to turn it up past the voltage that they recommend, and you can. It's not efficient, but you can do that. But it doesn't necessarily result in more it does have a power output, and that you're not going to achieve 6 millinewton meters from a motor that's rated at 3. It just doesn't work that way. So my philosophy has always been, okay, well, if we give them lots of power, then maybe we don't necessarily need all of that. And so we can go up to that and below. And that seems to make more sense to me. And especially if the rated speed of the motor is, let's say, I actually have it written down. I'm pretty sure it's like plus 2,000 RPMs, right? So that's a pretty big difference. I mean, when you're talking about the standard out there is about 3,500, and the ones that I'm producing here are doing about 5,500. That's a huge difference, right?
Massive, yeah.
And that's with our standard version. And then you step it up from there to the macro, and you'll get about another 800 to 1,000 RPMs at a rated, meaning, like, we're trying to give you honest numbers. When I talk about the 6.8, I'm talking about rated torque, basically like when it's under load in the circumstances, as close as I can get it to a real number, not just like look down the chart, find the highest number for torque, and that's the one we're going to advertise for, because that's, in my opinion, that's dishonest.
Yeah, I've never, I didn't even know that torque was measured in millimeters, to be honest. I don't know.
Millinewton meters.
What is it?
Millinewton meters.
Millinewton meters.
Yeah. So if you were to go to Europe, here we talk about foot pounds, right?
Mm-hmm.
So in other parts of the world,
I get it. Right.
They're using Newton meters.
Newton meters.
Millinewton meter is just a smaller measurement of Newton meters, basically.
Okay. Yeah. Can we talk for a second about it? And we may have discussed this on one of the episodes if we did one later after our initial kind of series, but you went through a handful of or a lot of trial and error with the material that you were machining the cams out of it. I don't know if we ever touched on it or talked about it. I know several people asked me about it when they would get a new set of cams or something in the mail and just be like, what happened? The first ones I got were black, and then these are this, and what's the difference? Would you mind going into kind of some of that, what that trial and error was?
Yeah, and actually we have new cams that I will be talking about as well. So this is probably
okay. Perfect.
Okay, so it's kind of a long process, but it started in the early days. We were machining the cam entirely with a CNC machine. Which was good, but there are limitations, and it's not cost friendly whatsoever. We're using a very high cost polymer that is technically harder and more durable than steel, and then lighter than aluminum. And so it's a really expensive material. It's hard to work with, and I can't remember. I think it was like something like a 20 or 30-minute part. Meaning like the machines, wow. 4 operations, so 4 separate processes within a machine, 2 different types of machines, and then 20 minutes or 30 minutes to produce one. So obviously that creates a lot of limitations, and so we had to think of a solution to that. So what we ended up doing was creating a mold that would make the cam with what we called it a blank. And so it basically, actually, I have one right here. So let's see, where's the camera? So here's a blank, right? So you see it's got this like wall here, And this is where the ramp will be cut from, but it doesn't have the ramp yet. That's where the profile will exist. So we would do that in the mold and then bring that to the machine shop, and then the machine shop would cut in the ramp. And that definitely works. And in a lot of ways, it's better because like all the little teeth are all super accurate. You get the mold right, and then you never have to worry about, deburring and stuff like that. What ended up happening is, this is actually a little embarrassing, I'll be honest, but we made it out of, I brought it to my molder and I said, we need these made out of PEEK. PEEK is that polymer I was telling you about. So he didn't tell me this, but he had some on the shelf that was left over from years ago that he never used. He didn't really know, what grade or anything like that. He just threw it in there and used it, and it was black. And we were cool. We got black cams, And then we started my machinist started telling us, oh, this material is really hard to work with. It's brittle. It's breaking, and so what I ended up doing was, because that was also failing, like we had sent some out and people were having problems with them. So then we ended up redesigning it. So you notice also that wall is really thin. So compared to if you've ever seen one of our other current cams. So what we ended up doing was redesigning it, make that wall very thick to give it more durability. And then in this whole problem solving phase, discovered eventually that he was using this old material. And he eventually told me, what happened was I started researching materials online and started finding, what are the different grades of this material? And is there something better? And so then I started requesting that he specifically order, and then that started the conversation. And we eventually realized it might have been an easier problem to fix if we had just used a better material. But anyway, we didn't. So now we had redesigned to make them more robust, and now we're using the best possible PEEK polymer that we could find. So that did solve the problem, and that is what we're currently using. However, go ahead.
I was just going to say, and it's funny, not being an engineer or machinist or that gear, that technical of a person, but whenever you move to the thicker wall, you also had to turn around and produce new bearing arms and everything else that fit inside the new cam. So like everything that you do, you have to kind of like look up and downstream and figure out what other aspects of the machine it's going to affect, huh?
Yeah, and it was a little bit of a nightmare and a huge learning experience, but because we had to change the bearing arm, that meant we had to go through our list of anybody who had bought one of these and send them replacement cam. We actually went through this twice, because first we made the one change of the thicker wall, then we realized the material thing, and we had already like recalled. So then we already had our list set up of everybody who was on the recall list, ended up getting two sets, one that was black and one that went back to the natural color. So
yeah,
that's what people were mentioning. Just because I wasn't, and so for each of those, they had to also get a bearing arm and a little explanation of what was going on, and replace this with this, and don't use that other stuff, So now I have experience with a product recall. So.
Yeah. I'm sure that was a costly.
It was costly, time,
time consuming.
Yeah, totally.
Yeah. So what you said that you're making new cams again, is this specifically for the macro, or is it for across the board?
All of them, yeah. So they all use the same mechanism. So when we make the change, we make it for all of them now. But
what prompted the most recent change in cams?
Well, okay, so that's a good question, because really, so the design of the macro prompted a whole lot of things, right? Because ultimately, well, this one isn't a good example. Let me grab one. Here's one of the original. This is a steel housing, but the inner housing, so all of these features are effectively the same. There's a couple of very small changes as the macro. It's just that it's longer, and you also have the bigger end cap, right? So it's quite a bit longer when you look at it this way.
It is. Yeah.
But technically this works with your old grip. So you could tattoo with it just like that, but you notice the third O-ring doesn't get in there. And so it's not ideal. It works, but it's not perfect. And so because we were going to have to design a grip that would cover that, and that would, it's not so much that it covers it, but it engages it and it provides that stability there. That's why Modus came to be, because we wanted the two to be interoperable. So that you don't have, so basically if you have one, you can also, you can use both. So you could have, let's say you have a Modus and you have a steel 33 grip, and then you also have an aluminum shift grip, because a lot of our customers do stuff like that. They want to try the different grips, they want to use them for different functions and stuff like that. So now you can switch the motor assembly of the Modus with the macro and vice versa.
Okay, that makes sense. I couldn't figure out how to phrase that question, but I was trying to think about the kind of order of operations and what prompted what. I understood trying the torqueer motor with the macro, but I didn't quite understand why the shift, what the point in the Modus was. So that's just so that everything can be interchangeable for the reason you just described.
Yeah, because the grip is the same. We only have one, so we have 4 different sizes of grips, but there isn't one for the Modus and one for the macro. They are identical.
Okay.
Now it's just a matter of and the cam is the same, the bearing arm is the same, everything is the same other than the ergonomics and the body of it, basically. So that's why Modus even came to be. That's why we figured, well, if we're going to have to make a new grip, why don't we just redesign and rethink everything, other than the mechanism, because we're happy with the mechanism.
Right.
But the reason.
Yeah, go ahead. I think you're about to answer my question.
The cams, right?
Right.
Yeah. So it's kind of a side story, because there's a couple of issues that exist with the process of making these cams. So we're still doing the 2-part thing. So you make them in the mold with the wall, and we bring that to the machinists, and they cut the ramp out of it. There's a few issues with that. Number one, when it comes off the mold, the plastic is kind of, it's melted, right? So it's like liquefied, and then it's shot into the mold and then hardened. And so the surface of it is really slick and really like hard, which is good, because especially when you have friction, right? You don't want it to be porous. So when you bring it to the CNC, the tool cutting the ramp creates a porous surface on the ramp, which is the surface that interacts with the bearing. So it's actually the worst possible place for having it be porous. But so ultimately the solution to that is to make okay, so let me start by saying the reason that it's that way is because we were like, oh, let's try adding this cam and this cam and this cam, and we didn't know how far we were going to go with that. And so to make a mold that has 8 cavities in it, one for each of, and then we want to try one more, and now we've got our mold is no good. And the process of making mold is very expensive and time consuming as well. So the solution, temporary solution back then, was make one that has the blank, and then we bring it right, so that way we don't have to make a mold that has every possible cam. So now that we've been doing this for a while, we regularly are using 12 cams. It's 4 different stroke profiles, right? The liner, the shader, the blender, and the packer, in 3 different stroke lengths. So so 12. And we're not changing that. We may or may not add in the future, but there's no immediate need for it. It seems like this is working. So now we're making a mold that has all 12 of them in one. And so we eliminate the need, or we eliminate the issue, well, the need for CNCing it and the issue of creating that porous surface. The problem with it is that when it's porous, it gets a little pitted in the ramp, and it's still functional, but it doesn't look very good, and I think it's causing it to wear a little bit faster than it needs to.
Gotcha.
And
Okay.
I just want it to be as close to perfect as I can create. And so while we're at it, we're going to make a couple other changes, because that all started because, well, first of all, like, you know that we have those little like dots and lines, and that's how you identify your cams. That's because we have a 4 cavity mold, so we can have 1, 2, 3, or 4 dots, and we have 4 stroke profiles, so that works. And then the lines are manually scratched into there to indicate the stroke length. And people can figure it out. We send them a key in the manual and everything, but it's not ideal. So now we can actually, since there's 12 separate cavities, we can just indicate on each one what it is, and they don't have to go searching in their manual to try and figure that out.
That'll be nice. Yeah, I actually got probably more questions on that through the Fireside, like either in comments on YouTube videos or in direct messages on Instagram about, do you know what the lines and dots mean? That was one of the more common questions that people were sending me. And I was like, I lost the piece. I don't really know. I know what the ones that I use. Actually, what I did right off the bat is I just went through with a Sharpie and I wrote what they were. And of course that's gotten smudged, but now I have them memorized. I just know what they look like.
Right. And we try to make them as like easy to remember as possible, but you know how it is.
Yeah.
So anyway, that's no longer a thing. So we're pretty happy about that. Another issue is, so this little hole in the nipple shape, that's basically a breather. So the motor shaft, this doesn't turn. It just goes up and down on the motor shaft. And so because the motor shaft is basically moving in and out of that hole, that cross hole is allowing air to go in and out. Okay. So it's not creating suction and like friction, basically. Problem with that is that's where you oil the cam. And so then once you start moving it up and down, it's spitting oil basically onto the top of the cam here and making a mess, making it look really bad. Oil does this process called lipid peroxidation. It's with all oil, it's unavoidable, where crystal clear, clean oil turns gray, or just darkens basically. So it ends up, people get confused, like, am I getting ink in there? I'm not really sure what's happening. Why does it look dirty? And obviously we don't want that. It's also like, this would make a great barrier if it didn't happen that way and all the oil could stay on that side. Then you would have your needle and cartridge mechanism on that side, and you would have your oil and cam and follower mechanism on the opposite side. But unfortunately that hole. So redesign that. So now it's actually being redirected back in the direction that goes in. Okay. And so there's a couple benefits to that. Number one, it doesn't spit oil onto the top of the cam, keeps this clean and dry, and also does that isolation I was just talking about. And then also, because it's coming back down the way that it came, it actually recirculates it inside it. And so you end up having to spend less time oiling, like quite a bit less oiling is necessary. So there's that. Yeah. And then we also kind of just like refined and perfected the little pusher at the very tip, just so it really seats as best we can with the cartridge.
Will the existing, I assume they will, the existing cams, if people are still, if they order the new machines, either of the new machines, will their existing cams still work, or do they need to ditch those and start?
Yep, yeah. They'll still work.
Yeah.
As long as they're not using I'm pretty sure nobody's using those anymore, but
the black ones.
The black ones with the thin wall. If you have those, throw them out and call me. I will send you free ones to replace it.
I didn't realize that thickening the wall was something that you did before you knew that the machinist had switched to an older material. So that was completely or possibly completely unnecessary. Huh?
Maybe.
Yeah. So frustrating.
The width of the bearing, like the reason that we made that change wasn't just to make it stronger, although that too, but the width of the bearing is the width of the wall now. So it didn't make sense to me that basically just the edge of this, or the edge of the bearing, was interacting with the wall. So I figured, why don't we just make the wall the thickness of the bearings, thickness.
Yeah.
So why don't I just really quick run through some of these, and if you have any questions, stop me.
Okay.
So the macro's rated speed is 1200 RPMs higher than the modus. That's pretty significant. Basically means that you can tattoo with it faster if you want, but it also still has more torque in the lower RPM, so you can tattoo slow with it as well.
Is there any correlation, or I'm sure I know there's a correlation, but is there a formula that connects voltage to RPMs? Like if I'm running typically at 6.5 volts, can I guesstimate at how many RPMs that machine is spinning at? Or?
Well, have you heard of the Tatcom?
Tatcom? I don't think so.
There's a guy who makes a power supply that does that translation. So there's a certain thing that you do with, like, he makes this cartridge that's not a needle, that you run it on a little pad, and then it determines at what voltages the machine is running, what speeds, and then you can switch back and forth between voltage or hertz and choose whichever one you prefer. But there are some, I've noticed that some manufacturers are starting to talk about hertz. So yeah, there might be a
way to do that.
Yeah,
I don't know what that would really tell me other than just like satisfy my curiosity. I don't know that it would affect anything about my tattooing. I'm just wondering.
Real quick comparison. Remember earlier I was saying that a lot of the other top brands are using the same motor. So we're going to call that motor 1, right? Or motor X. And then the modus versus the macro. So the speeds, as they compare those three, without load is 6,400 for the X, and then 8,000 for the modus, 7,400 for the macro. So it's no load speed, but the rated speed for X is 3,400, so about half of what the no load speed. And then for the modus is 5,400, for the macro is 5,800. So those are like actual numbers that you're most likely going to see when you're using it. And then the torque, sorry.
Just clarify real quickly that no load speed and rated speed. Rated speed means under load. Is that what they mean by that? Okay. You may have said that earlier, but I just missed it. I don't know. Okay.
And then the rated torque for those three is also, so for X is 3.1, for modus 6.8, and for macro is 10. And those are all fall hopper motors.
Okay, even motor X that you're talking about that a lot of manufacturers use is also a fall hopper.
Yep. So the more power in the case of the macro is going to result in this case, because it's not necessarily across the board motors in any application, but in this particular application, you'll see smoother power delivery across the speed range, more usable torque in also across the speed range, higher speeds under load, more range in general, meaning you'll be able to operate, say, at 5 volts, where before that wasn't enough hit or punch. The battery efficiency actually results in a better battery lifespan, which is actually just something that we are discovering, not something that we expected. One thing I would say that, and I don't know if you put this in or you don't put this in, but something that I noticed is that a lot of manufacturers focus on battery hours, like how many hours can you get? So, and then it's like up to, and it's always a number that is never achieved, up to 15 hours battery. And maybe, yeah, if you're one of the extremely rare circumstances where you barely turn your machine on, which is bad for the motor, by the way. But my opinion is that to focus only on battery consumption with regard to your motor is to completely neglect motor performance, right? That's like the give and take. If you're talking about if battery life is the sole thing we're after, then what you end up doing is getting a 3.1 millinewton meter motor that you've got to turn it all the way up in order to produce any result, and is not operating efficiently, and you are not operating effectively as an artist, in my opinion. So again, I don't know if that has any place, because I don't want to come off any certain way, and I'm never trying to like, I try not to compare, but of course,
It's hard not to. Sure.
you're producing tattoo machine.
Mm-hmm. Yeah, I'm with you on that. I mean, most people are not tattooing 6, 7, 8 hours without breaks anyways. And almost every time you buy, I mean, most battery systems that you're buying 2 batteries most of the time anyways. So if your battery lasts 3.5 hours, well, it's probably time for a stretch break, a bathroom break, and go ahead and pop the other battery on. Yeah.
We're finding about 7.5 hours at 8 volts. It's a 9-volt motor, so it's screaming at 8 volts.
Let me wrap it up with this then, because I know this is a question I'm going to get hit with a lot. Well, 2 questions. If someone's just buying their first Neuma, what are the considerations to decide whether to get the macro or the modus? If they already own the original N4, would it be worth it to buy the macro in addition to?
Yeah. So for people who have never used one, I would say modus is probably going to be a good fit for more people. If after hearing all of this, and I think people will know, like, are you the kind of person that wants to just get in there like traditional style, or a hard and fast style, or saturators, or solid color, or large scale, thick needle, large mag, something like that, then you probably want the macro. If that's not really what you do, and you are more of a normal, I don't know if normal is a good word, but like maybe more versatile artist, then probably the modus would be a better fit for you. And like I said, we still offer the original. We just call it Generation 1. And it's the same as the modus. It's a little bit cheaper. It's a little bit smaller. It's a little bit lighter. And we're talking like 10 grams or something, almost not noticeable. So if you're just looking for the basic of, there's also that option. And then the main difference between the two or the only difference between the two is ergonomics. And that's it. If no matter what you buy, you're going to get the exact same mechanism across the board.
Right. Okay. Yeah, I'm excited. I wish that the macro had shown up today. Like I said, I know I missed the delivery. I'm sure that's what it was. I had a sticker on the door, but I have been focusing. I'm tapering off my tattoo career a little bit at a time. I just had my 46th birthday, and I've told my wife I'm out at 50, except for the handful of projects that I feel like would be beneficial to the Fireside audience. So I would like to take on 5, 6 large scale tattoos per year and try to get through them efficiently, try to get as efficient as I can, because I've never been a particularly efficient tattooer. And so when you ask the question if I'm using larger needle configurations, and I typically don't, move into large scale, trying to do neck to knee back pieces or larger bodysuits or whatever. I've been thinking I need to get used to working with 20 plus needles, trying to get big fields of color, heavier lines, easier and faster. So I'm excited to try this thing out. And of course, luckily enough, I've got enough clients that are willing to give up large areas of space like that. And I've really been looking to simplify my process a lot over the last couple of years, just because my body's getting beat up like all of us who've been doing it for so long. And I want to continue to do larger and larger tattoos that that are engaging to me, but I need them. My body needs them to be faster and more efficient. I can't work at the pace that I work today and try to do, bodysuits. So.
Yeah. And I think that although like I was just to echo what I was saying earlier, the intended purpose was large scale, hard and fast, but it can do it all. It really can. If your thing is more like soft, delicate, then it's probably not for you. But any other approach is, it can do everything.
Yeah.
And even then, I think it can do it. It's probably just not the perfect application. And I think I saw a little bit of sadness in your eyes when you said you're done in 5 years.
Yeah, it is. It's this is I'm in my 27th year right now. I started when I was 20. So May was 26 years. And so that'll be, my 50th birthday will be 30 years. That seems like a good quitting point.
Yeah.
So I think, what about you? Are you thinking about, I know you don't tattoo as much as you did anyways, but.
Yeah, I don't think I will ever quit entirely, but I don't tattoo a whole lot these days, once a week or twice a week if I'm,
yeah,
I was gonna say if I'm lucky, but reality is that I just don't have the time. And, I use those opportunities to test new equipment and stuff like that. So
yeah.
I don't think I'll ever quit entirely unless my body's just like, screw you, buddy. Because one thing I noticed is that when I was a lot more active, I had a lot less back pain. And now that when it's, let's say I go a week without tattooing, or in some cases even 2 weeks, and then tattoo leaned over all awkward like I used to do it when it didn't matter, I'll have a sore back. I'll notice it much more. So
yeah, that's same here. And I find myself stretching and trying to drinking more water and trying to take better care of myself. It's funny how I spent so many years just doing whatever and not hurting at all and tattooing, all day long. And now I really, I focus on taking better care of myself, and it just doesn't seem to do any good. It just hurts.
Any like career change plans? And
for me, I want to focus more on Fireside. I've let it slide a little bit the last year or so. I don't want to get away from tattooing. I love traveling. I love hanging out and talking to other tattooers, who so many of them become my friends over the years. So I'd like to figure out. I enjoy the videography and the kind of storytelling aspect. I'm still not good with video and audio. I fumble through most every episode, but I do want to focus on doing like more, like better produced, fewer maybe, but better produced documentary style types of tattoo episodes. So that would be my goal. And now how I replace my tattoo income, I'm not exactly sure yet, but we'll see.
Hey, thanks so much for watching. I hope you got something out of that episode. I didn't mention it in the intro, but if you're interested in checking out any of the Neuma machines, the Modus, the Macro, or the original Neuma 4, you can enter the code Fireside at checkout to get 10% off of the machine and parts and accessories and all that kind of stuff. There's a link in the video description that will take you directly to our affiliate page, so that you get that discount at checkout. And I will do a review on the Macro myself in the coming weeks. I've only had this machine for a little while and I haven't had much of a chance to use it. So I'm going to use it for a couple of weeks, and then I will put together a little episode to kind of let you know what I think about it, and if I think it's worth owning both of these, or if you already own the Neuma 4, if you should or should not get the Macro. I'll give you my thoughts on that once I have a little more time to work with it. So thank you guys, as always, for supporting what we do. Really appreciate you, and we'll catch you in the next episode.